This video walks through the process of defining and creating an EVPN service using a workflow implemented in Apache Airflow and the Maat database. The router set parameters are located in the Maat database. Each router has a set of its own interfaces and is described by a number of parameters such as model, IP address, etc. Each interface in the Maat database is an independent object that has a relationship to one device router. Interface properties are described by a set of constant parameters such as name, description, and optional parameters such as tagging, speed, or encapsulation. For the interface to be ready to provide services, it must be in the active or ready state. Interfaces with tagging enabled are set to active state because they can terminate multiple services. The Services tab defines the services running in the infrastructure described by the resources. EVPN services are defined in the L2 EVPN category. The EVPN service definition consists of three elements: the main service instance, the bridge domain, and the service access point called SAP. Each service element can be created manually using Maat UI, but the recommended method is to use workflow processes. Input data for the workflow process can be entered in the Workflows tab by selecting the appropriate option. The basic service parameter should be its name and description. Then, select the EVPN service type from the list and indicate the preferred configuration template. In the next step, you should indicate for which clients the service will be set up. For the VLAN-based EVPN service, no bridge domain parameters are provided. In this case, you only need to select the router, the service termination interface, and VLAN ID. By default, two SAPs are defined. If the user requires more interfaces, they can be added by clicking the Add SAP button. Additionally, you can change the normalization and control word settings. The service startup process is carried out by the Airflow system. To initiate the EVPN service setup process, click the Submit button, which will launch the DAG process on the Airflow server. At the same time, the most important information related to the service creation process is available on the Mattermost Messenger channel. The service is configured on network devices using the Ansible playbook, to which the appropriate service parameters are passed. Ansible is run as part of the GEANT LSO subsystem. On the Mattermost channel you can also check the result of the service configuration on network devices. Detailed process parameters can be checked in the Airflow system. If the entire service setup process is completed successfully, it will be visible in the Services tab. As part of the service setup process, a VRF target identifier/community is automatically assigned and used in BGP signaling. EVPN service instances were created on network devices based on parameters found in the Maat database. The value of the identifier/community VRF target is assigned from the pool of available values defined in the Maat database. This data is stored in a category identifier object, which contains the next available identifier for a given service category. The identifier value is updated automatically as part of the workflow process. The parameters of the interface on which the service was terminated are also located in the Maat database. Reading these parameters is possible thanks to the interactive Maat UI interface. Service deletion is also carried out using the workflow process. To do this, select the appropriate service category and its name from the list and then click the Remove button. Then the appropriate DAG task will be run in the Airflow system and on Mattermost channel. The status of running tasks is visible in the Airflow control panel. After completing all tasks, you can check if the service still exists in the Maat database. The Airflow workflow removed all service elements from the Maat database, SAP points, bridge domain, and the main service instance. All references to and from the device interfaces were automatically removed by the Maat database. Removing configuration from devices is done using the Ansible playbook. Similar to creating an Ansible service, it's run within the LSO, and the information is also passed to the Mattermost channel. On the router console you can check whether the service and interfaces have been correctly removed from the configuration.